Good morning, everyone, and welcome to this math theological course in algebra. Our first course in algebra, we're going to be starting with section 1.1. We're going to go through the whole book. We're going to try to make this easy to understand, but we're also going to make sure we stop and understand the portions of the text that lead to information that can define or tell us more about who Jesus Christ is. 1.1, our first section is on evaluating expressions. Please note that definitions are key. You need to know your definitions. You must know your definitions. If we don't have definitions, we can't prove anything. I'm going to pause now for our first math theological point, which is the fact that some things are defined, but some things you must accept by faith. For example, the number 1. Define it. No, I didn't think you could. 1 we accept by faith as a number, a singular unit of something, but indeed it is accepted by faith that it exists. Same thing for most of our information. Our definitions come after we recognize what things are. Well, actually, what things we accept by faith, then we can have things exist. For example, in Genesis 1:1, it says, in the beginning, God created heaven, and we have to accept by faith that God exists, and then we can have some definitions. God created heaven and earth. Now we know what heaven and earth are because we accepted by faith that God exists. This section, for most of you, will be just a simple review. But for those for whom it is not, we'll go through it. Section 1.1. Again, you need to know your definitions for your examination. Know each and every one of your definitions. We're going to be talking about the definitions which are know what a power is, know what a base and an exponent are. These are two different things. But I'll define this for you. If I say a to the n, this will be your base. This will be your exponent. And the whole thing together is called the power. There's a singing group with Dean Lakeisha Williams here for. But if you were here for, no, class will get started. If you are here for camp meeting, the group Dean Keisha might be singing July 4th and 6th. The group is called Power. What a thought, what a name. Moving backwards just a little bit though, we actually need to know also what a variable is. These are all definitions here. A variable and also what an expression is. You know what expression is versus an equation. The equation, a hint on that one is that it has an equal sign. Moving on to the next screen. Alright, we're going to go now and make sure that we understand how to read and write powers. This, by way of words, is equal to 1/2 to the third power is how it's pronounced. Simple information. But we want to, again, evaluate the expression, so we must evaluate, which means that we must have a value. Value 8. No bad jokes coming on this one. I'll let you think of your own. Evaluate. So, for example, if I had what is a x to the third when x equals 5, evaluate that expression. An expression does not have an equal sign. Evaluate that expression. What will you do? Well, instead of writing x, whenever I see an x, I'd write 5. So instead of writing x, I'd write 5. So to evaluate this, it'd be 5. And anytime I want to evaluate, I would suggest that you use parentheses 5 to the third, which would be 5 times 5 times 5, which would be 125. evaluate the expression by substituting it into the equation. But anytime you substitute, you want to use parentheses. When substituting, use parentheses. When substituting, please use parentheses. Some of these are word problems in section 1.1, but I believe that might actually be the crux of the information from section 1.1. I would actually suggest that you, go back for a second, I would actually suggest that you go through some of these questions, especially the word problems, in this section so that you can understand what's happening. We'll actually go with number 49. But let's go through and do number 49 here and see what happens. I hope you have your textbook open if you're with us. We're on page number 6, number 49. Reading the question, you can estimate the distance that a leopard frog can jump using the expression 13L, where the L is the frog's length. What is the distance a leopard frog? What distance can a leopard frog that is 12.5 centimeters long jump? In this case, it's simple. They gave us that the expression representing the distance that this leopard frog, we'll call it a leapfrog. A leopard frog can jump, a leapfrog can jump is 13 times L. But they say when the leapfrog is 12.5. So in this case, all we have to do is substitute. We end up with 12.5 in parentheses L. Sorry, 12.5. Sorry about that backwards. Thank you for catching that. It's 13, and we substitute what L is, which is the 12.5, and 13 times 12.5 is, well, hopefully you have a calculator. 13 times 12 is 156, and then 6.5 more, which will give us 162.5. And if we keep our units, it will be in centimeters. That should be the end of section 1.1.